take a look at the data. That's the one we're working on today. From the objective, you can see that students will be investigating and represent various data collections. Students determine if they are functions and identify, analyze their characteristics. Students will also make predictions and critical judgment in terms of the problem situations. So as I mentioned, the test on Monday will look very similar to what you have here. All right, so here we go. On the first one here, you're given a table. And this table shows the latitude and average daily low temperature for several cities in North America and Hawaii. Now, this first part should have been very easy. All you had to do for me was create a point or an ordered pair based on each of these cities. So, for example, Miami here, they gave us a latitude of 26 and the average low temperature of 59. So all we're going to do is create an ordered pair based on these two numbers. And that ordered pair is 26, 59. That's all it is. Same thing for the next one, Honolulu. Ordered pair here would be 21, 66. All we're doing is taking the two numbers and making an ordered pair. Next one, Houston. Ordered pair here is going to be 30, 40. Next one is 40, 23. Next one, 44, 8. 32, 33. Next one, 40, 15. And then the last one, 33, 49. So all we did was take the latitude, those were the x values, take the temperature, those were the y values. So all we did was create some ordered pairs. That's all we needed for this first part. The next thing we're going to do is we're going to take each of those points and we're going to plot them on some graph paper. The problem is they really didn't give me much of this on this graph paper. So we're going to have to label some things here. Notice one of the things we're going to label is the x-axis. And it says here that we're going to label that x-axis as the latitude. So let's go ahead and do that. Down here, the x-axis is going to be the latitude. It also says that we're going to let the y-axis be the what? Average temperature. So the x's is the latitude, y's are the average temperature. Now notice they didn't give me a scale. They didn't tell me what to count by. So we're going to have to figure that out for ourselves here. So if I go back to my table here, and I take a look at the x's, which in our case is this first column, you'll notice that the largest x value I have in that column is a 44 right here. So what we're going to have to do is make sure when I label this is to make sure that I can get all the way to 44. So the question is, if I count by ones, am I going to make it all the way to 44? No. So help me out here. What can I use so that I can make sure I get to 44? 5s, 10s, 100s. All right, let's try 5. Let's see if we'll get to 40, at least 44, if we count by 5. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That looks like it's going to work perfect. Just enough room there to get to 44. So let's go ahead and do that. X values, we're going to count by 5. We're going to have to do the same thing for the y values. Look at the y values. First question is, what is the largest y value in the column? Everybody look. What is it? 66. So, I need to make sure that I can get all the way to 66. What are we going to have to count by here? Tens. All right, let's use tens. So we're going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. At this point, I've got my scale. I've got it labeled here. Now what I'm going to do is I'm going to take each ordered pair that we came up with earlier, and we're going to plot them. All right, so I went ahead. I've got my little table over here, and all I'm going to do is graph each of these points, each ordered pair. So if you haven't done that already, let's go ahead and do that. 2659. So let me find 26, and then I'm going to find 59. And this is just kind of eyeballing here. It's going to be right about in this area here. 2659. Then I'm going to find 2166. 2166 is going to be right about here. 3040 is the next one I'm looking for. Here's my 30. Here's my 40. 3040. Now I'm looking for 4023. Here's my 4023 is just slightly above 20. 44 eighths. So let's see here, 44 and 8, right down here. 32, 33, 32, 33, about here. 40, 15, 40, here's 15. And last one, 33, 49. 33 and 49, somewhere about here. So make sure you plot each of these points. Notice we had 1, 2, 3, 4, 5, 6, 7, 8. 8 ordered pairs, which means we should have 8 points on our graph. So make sure you have all 8. Now we can go ahead and move on to question number 2. Question number 2 says, describe any pattern in the data. What did we notice about the points here? Was there any kind of pattern? No. No? Didn't see no pattern. You didn't notice anything about the points, the dots here?
Goes down. They go.
Are they going up or the points going down?
Down.
They're going down, right? Notice how the points, they're going down, down, down. So, there is a pattern here, and that pattern is that the points are going down. Or we can say that as the latitude increases, in other words, as the x's are getting bigger, the y values, the temperature, is decreasing. Those numbers are getting smaller. As one is getting bigger, the other is getting smaller. If you didn't write this, make sure you write this. Number three, they want to know how do the table and the scatter plots reflect this in the data. In other words, how do we see this decrease? All right, the scatter plot shows as the latitude increases, the temperature decreases. You can see that in our graph. As the x's get larger, the y's get smaller. And I'm looking specifically at that last sentence. The scatter plot does show that as the latitude increases, the temperature decreases. As the x's are getting larger, the y values are getting smaller. Okay, we're going to turn to the next page, number 4. As the latitude increases, how does the temperature change? Well, I just gave you that answer. As the latitude is increasing, the temperature is decreasing. As the latitude increases, the temperature decreases. As one gets bigger, the other is getting smaller. The next one, number 5, are latitude and temperature a relation? Well, first of all, a relation. The other day we said a relation is a set of what? Ordered pairs. So the question is, do I have a set of ordered pairs? Come on, guys, wake up. Do I have a set of ordered pairs?
Sure.
Yes. As a matter of fact, how many ordered pairs do I have? We wrote them down.
More than one.
There's 8 of them. There were 8 different ordered pairs. And because there's those ordered pairs, we can call this a relation. All a relation is a set of ordered pairs. And that's exactly what we have, a set of ordered pairs. You're going to find that word relation show up a lot of here, guys. Relation, domain, range, functions. So we need to make sure we get used to those words, get comfortable. Number 6, they want to know what is the domain and the range of the relation. In other words, what are the x's and what are the y's for this set of ordered pairs? Let me start with the x's, the domain. Let's go ahead and make a list of those. The domain or the x's were 21, 26, 30, 32, 33, 40, and 44. You'll notice that when I wrote those numbers down, I wrote them in order. I don't have to, but it just makes them easier to account. If you didn't write them in order, it's okay. Just make sure you have each of those numbers listed. By the way, if any of the numbers repeat themselves, notice I didn't have to write it twice. Once is good enough. I did the same thing with the range, the y values. So all I did was go down the list and write down all the y values. I had 8, a 15, a 23, 33, a 40, 49, 59, and a 66. So all I'm doing is writing down the x's and then writing down the y's. That's the domain and the range. Number 7 wants to know if this relation is a function. Well, before we can answer that question, we got to remember what a function is. So what the heck is a function? What is a function? Where the x's don't repeat. So, did we have any x's repeat in our ordered pairs, guys?
No.
Any x's repeat?
Yes.
There was? Look at your table. Everybody look at your table. Look at the x's. Look at the latitude. Was there any
40,
of those numbers that
40.
repeated? Which one?
40.
40. So notice how the 40 repeated. And because that 40 repeated, can I say that this is a function?
No.
No. This is not a function. So write that down for me. This is not a function. And the reason it's not a function is because of that 40 that repeated. Can't have x's repeats. Not have x's that repeats.
My nightmares.
No, not a function. So on Monday, when I give you the test, you will see one that's very similar to this right here. Give you some ordered pairs, you give me the graph, and then you answer questions like this here. Relation, domain, range, functions. So make sure you're ready for that on Monday. Let's make it a little bit harder with this next one here. Just a little bit. This next one here, they want us to study the diagram below to determine the relationship between the perimeter and the stage. The perimeter and the stage. So if you look here, the first stage has a perimeter of 4. First of all, what is perimeter? Does anybody know what perimeter means?
The outside.
Yeah, it's the outside. What do you do with those outside? You add them together, outside. So, on the first stage, notice the perimeter is 4. So what I'm going to do is I'm going to go ahead and write that down in my table. So stage 1 has a perimeter of 4. The second stage, notice the second stage has a perimeter of 8. So let me write that down in my table over here, 8. The next one
12.
has 12. Now notice those are the only 3 they gave you. I didn't have any other pictures to look at, but we're still going to find those perimeters. But before we do that, let's take a look at the process column. How exactly did I get the 4? How did I get the 8? How did I get the 12? What did I do?
Add 4.
Well, we added 4, but there's another thing. What did we do with each of these stages? We multiplied it by 4. In other words, stage 1 times 4 is going to give me the perimeter of 4. Stage 2 times 4 is giving me 8. Stage 3 times 4 is giving me 12. So if I keep go ahead and doing the same thing, it'll give me the other. So the next one will be 4 times 4, which is going to be a 16.
20.
Then 5 times 4, which is 20.
That's 24.
6 times 4, which is a
24.
24. So even though I don't have the pictures to look at, it's very easy to find the perimeter on each of these stages here. Now notice this last one here, they didn't give me a number. What they gave me, it said, was a variable, a letter, the letter X. I want to go ahead and do the same thing I did with the others. The process. What am I going to write for the process here?
X. Oh, wait.
Well, notice what we did on the other ones, guys. Here we did 1 times 4, 2 times 4, 3 times 4, 4 times 4.
X times
So right here we should be putting x times 4. X times 4.
28.
Now the question is, what is x times 4?
28.
Nope, it's not 28. X times 4 is x4 or 4x. So write that down for me. 4x. 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 We're going to need that 4x in a minute, so make sure you do have it written down. Okay, let's keep going. Just like on the first one, we're going to have to create a scatter plot based on this table of data. So here we go. Before we can do that, let's go ahead and label the x and the y-axis. Let's go ahead and do that. First of all, the x-axis. What exactly is my x-axis? What are they going to represent? What is the x-axis? What am I going to put down here at the bottom? Huh? Nope.
Stage.
The stage. The stage is our axis. The y value, on the other hand, is going to be the perimeter. That's what we're going to put right here. Stage are the x's. Perimeter, those are the y's. Next thing I got to do is decide what is it that I'm going to count by. Well, if I look at that table again, the stage. The biggest stage I had was a 6. So I just need to make sure that I can get all the way to 6. So I can count by ones. It's not going to be a big deal. 1, 2, 3, 5, 6, 7, 8, 9, 10. No big deal. Let's look at the y's now. The largest y value we have, or the largest perimeter, is what? Everybody look at your table.
Count by 10.
So what is the largest y value?
It is 24.
24. So because our largest y value is 24, I need to make sure when I number over here that I can get to that 24. So what are we going to count by here? We can go by 1s, 2s, 5s, whatever is going to be more convenient for us. So what do you suggest here?
4.
What? I like that. Let's go with 4. So then we're going to go 4,
8.
8,
12.
12,
16.
16,
20.
20,
24.
24,
28.
28,
32.
2,
36.
36, and
40.
40. And we'll see why that 4 is going to work out perfect for us here in a second. So we're counting by 4s. Did I have to use 4? No. As long as you get to 24, you're okay. Okay, so now we've got everything ready to go. Now we're ready to start plotting the points. So here we go. Our first order pair. The first order pair was 1, 4. So everybody find 1, 4, put a dot. The next order pair we had was 2, 8s. Find 2, 8, put a dot. The next order pair was 3, 12. Find it, put a dot. The next one is 4, 16. Then we had 5, 20. Then we had 6, 24. Now can you see why it works out just right for us using 4s here? Anybody notice any kind of pattern with these points?
Up.
They're going up. They're going up. Keep that in mind. They're going up. So let's take a look over here at the questions. Number 10. They want to know what pattern do you observe in the diagram? Well, you just said it. It's doing what? It's increasing. It's going up. It's increasing. How are they represented in the table and the scatter plots? Well, we can tell from the table because the dots or the points are increasing. They're going up. We can tell in the table. How exactly can we tell in the table? Well, as the x's are getting larger, what's happening to the y values? They're also increasing. So as one gets bigger, so does the other. Okay, we're on number 11. Number 11 wants to know, does this data represent a relation? Remember, relation is a set of points, set of ordered pairs. So can I call this a set of points, set of ordered pairs?
No.
Let me go back to the graph here, guys. What do I have on the graph? What are these green things? They are
Dots.
points. They're ordered pairs. So, do I have a relation? Yes, you have a relation. You have a set of points. You have a set of ordered pairs. Anytime you have a set of ordered pairs, it's called a relation. Function. Does the data represent a function? Well, in order to be a function, we got to make sure that none of the x's repeat. So go back and look at your information, look at your table there. Do any of the x's repeat?
No.
Ethan, do any of the x's repeat?
No.
No. So can I call this a function?
No. Yes. Yeah.
Yes. As long as no x's repeat, you can call it a function. So number 12, yes, it is a function. And the reason it's a function is because the x's don't repeat. X's don't repeat. Okay, number 13, they want us to identify the independent and the dependent variables. So, Diego, you're going to help me out with this one, all right? 13, independent, dependent. They want to know what are the x's and what are the y's. So I want you to go back to your table for me. Get your table. And the x values, what did they represent in the table? The stage. And what did the y values represent? The perimeter. All right, very good. So our independent is the stage. The dependent is the perimeter. So write this down. Independent is stage. Dependent is the perimeter. In other words, the perimeter is going to depend on what stage I'm talking about. Dependent is perimeter, independent is stage. Okay, number 14. Number 14, we want to know, is it continuous or discrete? So, Johnny, let me remind you what those two are first before you answer this question. Discrete means when the dots are not connected. Continuous means when the dots are connected. So my question to you is this continuous or is it discrete?
Discrete.
And why would it be discrete?
Why is it-
You can do it. Why? I just told you why.
I don't know.
What did we just say discrete was?
Why
It's
is
sitting
it-
right over there next to you. Look at the board. What does it say discrete is?
Any of the points that would not be connected on your graph.
And what kind of points did we have on our graph? Points that were
Okay,
not connected. So why are we calling it discrete again, Jen?
so they're not connected.
Because they're not connected. So it's discrete because the points are not connected. And you'll notice it's very important here, we cannot connect these dots because we are talking about stages here. There is no such thing as 2.5 stages. There is no such thing as 4.5 stages. For number 15, they want to know whether we have an increasing or a decreasing relation. All right, so Zoe, what do we have here? Increasing or decreasing? Look at the points. Notice what those points are doing. Are they increasing or decreasing? Increasing. That is correct. Increasing. Those points are increasing. In other words, as the x's get larger, the y values are also getting larger. Now the last two are a little bit tricky, so I'm going to slow it down here on the last two. Number 16 says for us to find f of 34. We did this the other day in our notes. However, in order to do this, I've got to have a function. I've got to have a rule here. So the question is, what is that rule? F of x equals what? Well, we've already wrote it down.
Can I sit behind Amber?
Yes.
I can't see.
We've already written the rule down. It's in our table. Let me go back to the table so you can take a look. It's right down here. This is our rule. That's what we're going to be using so that we can answer the last two questions on this section here. So let's go back. So now that we know the rule is 4x, now we can find f of 34. So here's how we did it. In order to find f of 34, what we did was replace our x with the number 34. In other words, we're going to figure out what is 4 times 34. So if you use your calculators, 4 times 34 equals to a 136. So write this down for me. F of 34 equals to a 136. In other words, the temperature, I'm sorry, not the temperature, but the perimeter is 136 at stage 34. That's what this is saying. 136 is our perimeter at stage 34. Last one here, number 17. Is it possible in this situation to say that f of x is equal to 85? Would that be possible?
No,
Why not?
because all the numbers are equal.
They're even, or they're actually multiples of 4. So no, this is not possible. The reason it's not possible is because we have all of our y values that are multiples of 4. In other words, it's always 4 times something to give us this y value. And there is no 4 times something to give us an 85. All right, so we've done 2 sections together. We've got one more section here, and I'm going to get you started on that section, and then I'm going to have you finish it up on your own. I'm going to get you started, and then you're going to finish it up. Here it is. Last one is no, because it's multiples of 4. All right, I'm only going to do this part for you, and then after that, you're going to be on your own. The next one here says that the area of a rectangular pool with a perimeter of 800 feet is given by the formula f of x is equal to 400x minus x squared. X is going to represent the length of the pool in feet, and the f of x is going to represent the area of the pool in square feet. What we got to do first is finish up this table, create a table. So here's how we're going to do it. You're going to need your calculator for this, guys. What we're going to do first is plug in a 0 in for the x's in our equation or our function. So what I need you to do is in your calculators, you're going to type in 400. Everybody get your calculators. 400 parentheses 0. Close it up. All we're doing is taking out the x and replacing it with a 0. Minus. I have another x. I'm going to replace that x with a 0 as well. And then don't forget the little square here. So this is what it should look like in your calculator. When you have that in your calculator, hit enter.
It's a 0.
And what number do you get?
No.
0. So right here we're going to have 0. We're going to do that again. But instead of using a 0, this time we're going to use a
50.
50. So let's try that again. Instead of using 0, use a 50 this time. Put it in your calculator. Let's see what number we get.
17,500.
17,500.
500.
Let's keep going. Let's try this again. This time we're going to use 100 for the x's. Let's see what number you get this time.
30,000.
30,000. do one more here together. Next number I'm plugging in is 150.
37,500.
Put that one into your calculator, and you get
3,700.
37,
3,700.
37,500.
There you go.
All right, so here's what I want you to do. I want you to go ahead and continue with that same pattern. Keep doing the same thing with your calculator. Finish up the table for me. When you get done with your table, come over here and set up your graph, just like we did on the other two. Tell me what the independent, dependent are, the x and the y. Tell me what you're going to count by, and then start plotting your points. Once you have the points plotted, then answer your questions 21 through 25. You've got two examples that we did together so that you can go back and look at. So finish that up one.
Whenever we're done, let me make it in.